So we're solving systems using substitution. So we know substitution means replace. We talked about that. We know that substitution means plug it in, plug it in. So that is what we are going to spend our time doing today. You will always have an x equals something or a y equals something. So the first example is the following. X equals 3, and then x plus 3y equals 9. So, I know that x is 3. That's what x is. It's 3. So now I'm going to look at my second equation and do what? Plug it in. Plug it in, plug it in. So I'll even do like a different color, circle it, and show you here. So this is like equation 1, and this is like equation 2. I'll write some steps for you in case that helps. Plug in 3 for x in equation, I'm going to call it B. I want to do A and B. Okay, so do it. So you're going to rewrite the second equation, x plus 3y, but you're not going to put x. You're going to put 3. 3 plus 3y equals 9. You're just replacing. Okay, now all I have on my problem here is a y. I'm going to solve for y. Go ahead and do it. Get rid of the 3. Minus 3 BS. 3y equals 6. Okay. Last step, easy. Y equals, is it 1/2 or is it 2?
2.
Yeah.
Good. I'm halfway done with my ordered pair. Y is 2. Okay, so that was step 1. Step 2 was solve for y. We did that. Step 3. What would you say step 3 is, if you had to guess? But how do I solve for x? I know y. I know the letter y. It's
Plug in y.
plug in 2 for y into the OG, original. Which one do you want? Original, the one that's typed on your paper. Yeah.
Isn't X already given to us?
Oh! X is already given to us. Did you notice that? So you're done. X is 3. I didn't even have to do anything. It told us X was 3. How easy is that? If you felt like you were still going to plug it in, you would have to pick the second equation, and you would do x plus 3 times 2 equals 9. X plus 6 equals 9. And there's your proof that x equals 3. And you have your ordered pair x comma y, and you're done. Okay, let's go into our second equation. X equals 2y. And then 2x plus 3y equals 10. Nice. I either look for x equals or y equals. Which one is given to us? X equals. So circle it, this 2y, and where are you going to put it?
In parentheses next to the 2x.
In for x, because that's what x is. It's 2y. Now it has to be in parentheses, smart. You're not going to put 22. You've got to separate it so it's 2 times 2y. 2x, which is 2y, remember? Plus 3y equals 10. I don't need to put the x anymore because I've replaced x and I have something else for x. Okay, 2 times 2y is what? 4y. Plus 3y equals 10. Okay, and I get 7y equals 10. It's good practice for us because we're going to get a fraction answer. And it is totally fine to have 10/7 if you want to write one mixed number, right? And 3/7. But for our purposes, putting in 10/7 is going to be a lot easier. Which equation would you like to plug it into? I know that y is 10/7. How do I find x? Not every question. A lot of you are quiet today. Let's hear from you. Which equation would you like to plug it into? The top one. So smart. So here it is. X equals 2y. Y is 10/7. Don't write y. Put 10/7 there instead. And then do the math. Multiply straight across. It basically looks like this. 2 over 1 times 10 over 7. What is my x, ordered pair? (20/7). And you're like, well, that's the ordered pair that fits into both of them. It is. And if I graph them, if you wanted to graph them, it would be 2 6/7 over to the right, and then 1 3/7 up, which would be kind of in the middle of a box. You wouldn't hit a corner at all. This is where these two equations would hit if I graphed them. This is also the solution. Then an ordered pair that would plug into both equations and I'd get a yes. Okay. Third one. Y equals 3x. X plus y equals 4. Try this one on your own. I wonder if I recorded the last slide. I don't know. The transitive property. So this is number 4. Okay. I'm going to use Caitlin because she's in front of me. Here's a piece of chocolate. I like chocolate. Caitlin likes me. So what can I say about Caitlin? If I like chocolate and Caitlin likes me, what can I say about Caitlin? She likes chocolate. And of course it's like, well, maybe she doesn't. Maybe she's allergic. Of course there's an exception to every rule. And somebody can always argue and be a pain in the butt and be like, well, what if... Okay, but the point is, that's how it works. If I like chocolate, but Caitlin likes me, then we can assume logic. Maybe Caitlin likes chocolate because I like chocolate and Caitlin likes this stuff about me. So with transitive property, I've got y equals this, and I got the second equation, y equals that. So with transitive property, what can I say about my 6x plus 13 and my negative 3x minus 14? If they both equal y, what can I say about them? They're alike. I like that. That's true. If they both equal y, what can I say about them? They're both going to be the same. I like hearing that. That is true. But mathematically, what conclusion can I come to? If they both equal y, let's say they both like y, what can I say about each of them? My red circles. I just said that. They both equal y.
So they're going to equal each other.
They can equal each other. If they both like y, they both are equal to y, they equal each other. And it's true. If I just replaced one with the other, I would have these two equations equal to each other. So here it is. 6x plus 13 equals negative 3x minus 14. If they both equal the same thing, they equal each other. If they both equal the same thing, they equal each other. So now what am I solving for? What's the only equation what's the only variable I have now? X. That's what you solve for. Because the y's got canceled out because I put these two equal to each other. Okay. Now here's it's been a while. I think it's smarter if you move the smaller variable over. Which variable is smaller, 6x or 6 or negative 3? Negative 3. How do I move negative 3? So I'm going to add 3x, and remember, like terms, I can only add it to the 6x because they both have an x. So I'm going to add 3x to the 6x, and I'm going to do my math. 9x plus 13 equals nothing. Negative 14. And I'm still solving for x. Like terms, get the 13 and the 14 together. Subtract 13 both sides. 9x equals, is it 1 or is it negative 27? Negative 27. Okay. And then let's get x alone still. X equals negative 3. Halfway done. Negative 3 comma, I don't know what y is. But I know that x is negative 3. Which equation from the original would you like to plug in your negative 3 into? Top, sure. Let's even pick a different color so I've got like a brand new fresh start. Y equals 6x, because x is negative 3, plus 13. Y equals 6 times negative 3, because, that's x, plus 13. Do not write x anymore. Put the negative 3 there instead of it. And do the math. Negative 18 plus 13. So we're back to one-step equations, two-step equations, solving integers. Negative 5. Y equals negative 5. Does this seem fair enough to you? Okay. The next one's even easier. Hey, they both are y equals. Y equals. If they both equal y, what can I say about them? They equal each other. So set them equal to each other. Set the equations equal to each other. Equal to each other looks like this. You're basically putting this 2x there. 2x equals negative 2x minus 4. Because the y's are going to end up canceling out because they equal each other. So you just set the equations equal to each other. And you solve for x. Get the x's together. Move the smaller one. I've got a 2 and then I've got a negative 2. Move the smaller one over. Four x equals negative 4. And my answer is, divide both sides by 4. X equals negative 1. I'm halfway done with my ordered pair. and plug your -1 into whatever one you want. Which one looks easiest? Of the original, the ones that are black printed on your paper. Those are the originals. Top, sure. Y equals 2x. Instead of x, put what we just found. We found it to be -1. And obviously, 2 times -1 is -2. Y equals -2. So you're plugging something into an equation, and then you are solving for a variable. And we'll stop there so that you can get as much done as you can on classwork. So we'll just stop at example 5. This was 5. And start our classwork.